So question 4 and 4c, two roads intersect and we're given the diagram here at a point O and cross at an angle theta such that the tan theta is 3 over 4. Okay, so straight away I'll just write down sine theta. We know we're going to do a tan theta 3 over 4 leaves me with 5. Sine theta is 3 over 5. Two cars A and B are traveling towards these roads, A at 5 meters per second and B at 8 meters per second. And it tells us that B is 200 away and A is 100 away. So A is 100 away at 5 meters per second. It's going to take 20 seconds to get there. Is that quicker than B? B is 200 away. Yeah, you can see it's 200 away at 8 meters per second. So it's going to take 25 seconds to get there. So we get A to get there first. So we have A at the junction and we have B a distance away. A, B. So in 20 seconds, B is going to go 8 by 20, which is 160 meters. So it's going to be 40 away. 200 minus 160. So now we're asked to get the time at which A reaches O. Well, the time is in 20 seconds. The distance between A and B at this time we have is our 40. So these questions, you can always do the parts before looking at them. That would be the first two done. The magnitude and direction of the velocity of A with respect to B. The velocity of A is equal to, so A is traveling at 5, so the velocity of A, what direction it's going? It's going down this way and going in this direction, so minus minus. So minus 5 by the cos of the angle in the I direction, minus 5 by the sine of the angle in the J direction. So write down our cos theta up here, 4 over 5. So minus 5 by 4 over 5 in the I direction, and minus 5 by 3 over 5 in the J direction is the velocity of A, which is going to give me minus 4I minus 3J. The velocity of B is equal to, it's going in the minus I direction, so minus 8I. And we're looking for the velocity of A with respect to B. The velocity of A with respect to B is the velocity of A minus the velocity of B, which is going to be minus 4I minus 8I. So that's going to, you can write it down or you can skip a stage, but let's just skip this one. We're going to be minus 4 plus 8, so 4I, and it's going to be minus 3J. So 4I minus 3J, not I, J. That's the magnitude and the direction. So the magnitude of the velocity of A relative to B, you can see it's going to be 5, 4 squared plus 3 squared, which is equal to 5 meters per second. The tan of the angle, are we asked for the direction? The direction, yes, the tan of theta is my 3 over 4. So theta is going to be this 36.87. That comes up a lot. And what direction is that going? It's going positive, negative. So it's going in a positive, negative direction, which is south of east here. So that's south of east, or SOE. The shortest distance between them. Okay, we'll do another diagram for that. So we have our 40. My A, my B, my 40. Velocity of A relative to B, and my distance and my angle. So we have the tan of theta is equal to 3 over 4. So the sine of theta, tan is opposite, so sine is opposite over hypotenuse, has to be a 5. So the shortest distance, you can see what it's going to be, sine of theta is equal to O over H. So 40 by the sine of theta is equal to my shortest distance, which is equal to 8 3s, which is 24 meters. Next one, the time at which they're nearest each other. So we need to get this x along here. So x is going to be the square root of my hypotenuse squared minus my shortest distance squared. So x is going to be 32 meters, and The magnitude of the velocity of A relative to B is 5. We can see that from our 3 and our 4, so that's equal to 5. So 32 divided by 5 is going to be 6 and 2/5, 6.4 seconds. The time at which they're nearest one another. And then the time when they are equidistant from O. So just before doing part 5, the time which they're nearest to one another, 6.4. A has been travelling before this for how long was it at the beginning? 20 seconds. So it's actually at 26.4 seconds. 26.4 seconds is when they are going to be nearest each other. So we look at when they're going to be equidistant from O. So A is travelling towards O at 100, and every 1 second it's going to be 5 closer, so minus 5t. And B is going to be travelling towards O, it's 200 away, and every second it's going to be 8 closer, so minus 8t. So that should solve for us. 8t minus 5t, 3t. There's going to be 100, so after 33 and a third seconds, they are going to be equidistant from O, which is the last part of this question.